Hi, my name is Pierre-François Gerard and I completed my PhD in computer science in Goldsmiths University in London, UK. My main research focus was to evaluate the effectiveness of architecture in immersive virtual environment. My background is in architecture and 3D visualization, so over the years I built a series of virtual reality applications using architecture as the main variable. To understand the potential effect of this spatial design on cognitive performance, this first study focused on memory. Ed Cook, a memory champion, has memorized a shuffled deck of cards in competition in 43 seconds, using some variations of the method of Loci, also known as the memory palace. These memory champions memorize the cards by imagining a journey with a sequence of places, or Loci, and mentally tracing their step back to recall each card associated in each location. This approach requires many hours of practice to visualize these Loci in one mind's eye. What if we could create these palaces in 3D so that anyone could train their memory by practicing with a virtual reality headset? But then, how to design these Loci? Is there a particular layer that works to enhance people's memory? What spatial qualities improves learning? What are the cognitive principles behind the method of Loci, and how can we apply them in VR? I started developing this study in 2014 with the Oculus DK2. Participants were present in the virtual environment, but still using Xbox controller to move around. This sounds very outdated 6 years later, isn't it? Well, still, this virtual environment had already participants' full attention. And learning and memory are interlaced. So, for the case here, I've isolated three main theories that explain the principles behind the method of Loci. The first theory is the dual coding theory by Pavio, who encouraged to use both words and images to improve retention. The second theory is context-dependent theory by Bedley and al., showing that the recall performance from participants was much improved when situated in the same place as where the original learning occurred. And the third theory is called working memory, the 7 plus or minus 2, exposed by Henry Miller. So the first part was to evaluate participants' memory capacity using a web-based memory card layout. Participants were able to see the sequence of random cards, then recall them on the following screen, as you can see here. We had a total of 18 participants. To compare the effect of different architecture on memory performance, two different environments were designed. The first environment was based on a typical Palladian plan with multiple interconnected rooms and perpendicular walls. The second environment was called the curved palace, designed with features seen as in opposition to the Palladian palace, with no sharp corners and no symmetric arrangements of architectural structures like columns and doors. Following the method of Loci, a second level of association was added by placing a series of frames on the walls. In each frame, participants had to choose one image from a series of images to associate the playing card with. Each image represented a well-known archetype that could easily evoke a narrative. The first goal of the study was to examine the recall accuracy difference between a control experiment using a desktop monitor and the virtual memory palaces. Participants using the virtual memory palace had an average increase of 32% in recall accuracy compared to those using the screen-based version. Of course, this comparison is somewhat limited, as the aim of the virtual memory palace is to develop a new form of active learning methodology by encouraging the association between place, image, narrative, and playing card. Now, when comparing participants' performance between the two different palaces, we use cycle time as a performance metric. A good learning method should lead to a more efficient way to remember any given unit of information, so that consequently the system should afford a shorter cycle time. Disappointingly, our sample size did not show any statistically significant difference between the mean cycle time of the two palaces. Next iteration of this experiment will require more participants, as well as having them run in each space more than once. Lesson learned. However, from a qualitative standpoint, each participant feedback, as well as their mental map sketches, brought many valuable insights. For instance, even though the curved environment showed a trend towards a faster cycle time, maybe due to less choice of directions, maybe less connections between rooms, participants were better able to orient themselves in the Palladian environment, mostly due to the rectangular and symmetrical layout. These are only a couple of areas to explore further when designing immersive virtual learning environment. Realizing the lack of objective measure of spatial qualities in this study, I decided to look further into how architects were actually evaluating the effect of physical architecture on people's life. In fact, in parallel with the development of three-dimensional visualization tools, architects have been working with analytical tools using the power of computers to provide complex analysis. In a pivotal study, Benedict and Hillier demonstrates how to use an isovist to measure these spatial characteristics. In a follow-up study, we are evaluating the effect of various spatial qualities such as layout complexity and spatial openness using this isovist technique to understand the effect of these spatial qualities on learner performance when completing demanding cognitive tasks in virtual reality.